So in our final section of Chapter 3, Section 6, we're going to be working with solving radical equations. And our key vocabulary here is what is a radical equation. That's pretty simple. It's just equations that have radicals in them, right? And then this introduces a new concept of an extraneous solution. And these are tricky. So an extraneous solution is a solution that you have solved for properly algebraically, but it's not actually a solution. So it's a false solution. And the way you identify them is by plugging them back into the original function. If it makes a true statement, it is a solution. If it makes a false statement, then it is an extraneous solution, and it should be omitted from your answer. So when you're asked to find solutions, the reason you want to check for extraneous solutions is because they look like they're solutions, but they're really not. So radical functions would look something like this. We did this also in the last section. This is a problem that relates the age of an elephant to his height at the shoulder. So we're going to work on this problem at the end of the section, but this is sort of what a radical equation looks like. And then the skills necessary to solve radical equations are what we're going to use to solve this problem back at the end of the lecture. So the steps for solving radical equations is first you want to isolate the radical on one side of the equation if there's only one. Then you want to raise each side of the equation to the same power to eliminate the radical. And so what you're going to do is you're going to take each side of the equation to the inverse power of the radical. So remember, radicals are powers that are fractions, so then we'll take the either side of the equation to a power that is the inverse of the power that we already have. Now we might get a linear function, a quadratic function, or a cubic function, or something else once we do that, and we may have many other steps to solve, but this is the process. So then we solve using techniques we've learned in chapters 1 and chapters 2. So then we'd want to check our solution to see if we have extraneous solutions. Let's go ahead and go and do some problems. So these problems all have a single radical in them. I want to isolate the radical on one side of the equation. This one's already there. So what I want to do is I want to take either side of this equation to the second power. So I'm going to square both sides because squaring gets rid of a square root. If you think about this in terms of rational exponents, this could also be written as 5x plus 1 to the 1/2 power. And the way I'd get rid of the 1/2 power is I would square it. So 5x plus 1 to the 1/2, and then I square it because 2 times 1/2 equals the first power. So I'll get 5x plus 1 over here. And if I square the left side of the equation, I also square the right side of the equation. Subtract 1 and divide by 5. So then I'll have x would be equal to 36 minus 1 is 35, divided by 5 would be equal to 7. All right, I'd plug that back up into my original problem. 5 times 7 is 35, plus 1 is 36. Square root of 36 is 6. 6 equals 6, that checks out. Okay, so over here, I want to isolate the radical by adding 2/3 to either side of the equation. And then I'm going to square both sides of the equation. 2/3 squared is 4/9. Then I'm going to divide by 2, or you could think of it as I'm going to multiply everything by 1/2. So this becomes x, and over here I have 4/9 times 1/2. Well, this 2 goes into the 4 and leaves 2, and this becomes 2 times 1 in the numerator, 9 times 1 in the denominator, 2/9. Then I'd plug that back up into the original problem, and it does check out, and it will be a true statement. Okay, over here I would add 7 to either side. We have a little extra work to do, and now we have a cubic function now. Once I've added 7, now I'm going to divide by 3. So I have the third root of 16x would be equal to 8. And now I'm going to cube each side of the equation. So I'm going to have 16x would be equal to 8 cubed. So 8 cubed, let me grab a calculator really quick because I'm not sure I want to do that in my head right now. 8 to the third power is 512. So x would be equal to 512. That's 8 cubed divided by 16. So let me go back to my calculator and divide it by 16. That's equal to 32. Okay, so I used a little bit of technology in this. I could also plug this back up in here and check, but we're going to work on extraneous solutions a little later. What I want you to get used to is the concept of isolating the radical and taking either power to the inverse power of the radical. Third root of x, if I add 10 to either side, would be equal to 7. X then will be equal to 7 cubed. 7 cubed is 49 times 7, but I'm going to go ahead and go back to the calculator. 7 cubed is 343. Okay, so that's the way you work through these problems. You go ahead and practice. Do problems 4, 5, 14, and 15, and then come on back and we'll do some more examples. So over here, this is a little more complicated. These are rational exponents, so they're writing it in a different form. These, you can see, also involve roots and powers at the same time. But what I'm going to do essentially still ends up being the same. To get rid of the 1/2, I'm going to multiply both sides of this equation by 2. So I'll have x to the 5/2 is equal to 32. And then I take both sides of the equation to the inverse power of this. So this is 5/2, so I take either side to the 2/5 power. 32 to the 2/5 power. So 5/2 times 2/5 equals 1. That's why I picked it. Inverses, when you multiply them together, equal 1. I want x to the first power. And now this is the 5th root of 32 squared. So if you want to think of it this way, sometimes that helps you to think about it. I can also plug this directly into my calculator and simplify it. But I think it's easier to do the root first and the power after. So if I think about the 5th root of 32, that's 2, because 32 is 2 to the 5th power. So then I'll have 2 squared, so x would be equal to 4. If you wanted to put this into your calculator, right, over here, I would do 32, up caret, open parentheses, 2 divided by 5, close parentheses, enter. Okay, and that will get me directly to 4. Okie dokie. So you can use your calculator, or you can work with and do mental math to do this. Either way you would like to do it. Okay, over here I want to isolate my radical. I'm going to divide both sides by 2. And then I'm going to take either side to the inverse power, to the 3/2 power. Now, 16, the square root of 16 is 4. So this is 4 to the 3rd power. 4 to the 3rd power is equal to 64. All right, so you go ahead and practice this. Do problems 27 and 28. And then come on back to the lecture. Okay, now we're going to talk about the idea of these extraneous solutions. So again, extraneous solutions are solutions that I solve for algebraically, but they aren't real solutions. So I've got a square root here. I want to make sure I square both sides of the equation. Now remember, x minus 6 squared does not equal x squared minus 36. Right? This is a binomial. We've already learned how to multiply binomials. I know that this is going to be x squared minus 12x plus 36. And when I square the other side, I get 3x. Now, remember, the method I'm using is a minus b squared is equal to a squared minus 2ab plus b squared, which I learned in chapter 1. Okay, so now I want to set, it's a quadratic function, I want to set it to be equal to 0. I subtract 3x from either side. And then I want to find factors of 36 that add up to be 15. That would be 12 and 3. And I factored, and I can solve for x is equal to 12 and it's also equal to 3. Now when I plug this back up into my equation, if I plug 12 in, 12 minus 6 is 6, right? 12 minus 6 is equal to the square root of 3 times 12, right? So 12 minus 6 is 6, square root of 36 is 6, so that works. But when I plug 3 in, right, 3 minus 6 equal to the square root of 3 times 3, I'll get negative 3 is equal to the square root of 9, and that is not true. Okay, so 3 is an extraneous solution. 12 is my only solution to this problem. So this is what we're talking about with an extraneous solution. They normally come from doing even powers and even roots. Okay, we're pretty safe with odd powers and roots, but when you have even powers and even roots in the process of solving, it creates the possibility of these extraneous solutions. So go ahead and do some practice on this. Do 36 and 37, and then come on back to the lecture. Right, now these problems are a little different in that I have more than one radical. So when I have more than one, I have, like, a problem like this is very simple. I want to move it to the other side, move one of them to the other side. By adding this radical to both sides of the equation. And now if I take both sides to the third power, I'll get 12x minus 5 is equal to 8x plus 15. This is a linear equation, very easy. Subtract 8x, I get 4x. Add 5, I get 20. So x would be equal to 5. Very simple. When you look at this problem, it's a little more complicated because of this plus 1. This plus 1 creates all sorts of problems. I can still solve it, but it's going to take a lot of extra steps because it's not as easy as getting the radicals on either side of the equal sign and then squaring it. I'm going to have to square it as it is. When I square the square root of x plus 5, I get x plus 5. But when I square this item, again, I'm going to get, right, a plus b, right? That's what I have. This is a plus b will be equal to a squared plus 2ab plus b squared, special patterns from chapter 1. So when I square 3x minus 8, or the square root of 3x minus 8, I'm going to get 3x minus 8. And then 2 times 1 times 3x minus 8, it's going to be 2 times the square root of 3x minus 8. So the problem here, and then plus 1 squared. The problem here is I still have a radical. But what I'm going to do now is rework combine like terms. So when I go ahead and combine like terms, I still want to isolate the radical here. So I'm going to subtract 3x from either side. That'll give me x minus 3x is negative 2x. I'm going to add 8 to 5, that's 13, and subtract 1, so that would be 12. All right, and over here I have 2 times the square root of 3x minus 8. So I'm still going to continue on. I want to divide by 2 to keep isolating this radical. And when I divide this all by 2, I'll have negative x plus 6. And now I'm going to square both sides of the equation again. Now I'll have 3x minus 8. And I'm going to square this. It's going to follow the same pattern as this. So I'll have negative x squared, which is x squared. I'll have 2 times negative x times 6, so that's going to be minus 12x. And I'll have plus 6 squared, which would be 36. Now I have a quadratic function. I want to combine like terms again, make it all equal 0. So I'm going to subtract 3x from either side. So negative 12 minus 3 is minus 15x. I'm going to add 8. And I want factors of 44 that add up to be 15. Well, that would be 4 and 11. So I'll have x minus 4 and x minus 11. So my solutions are x would be equal to 4 or 11. And I would want to plug those back up here to check for extraneous solutions. Okay, so I'm not going to go through that process. I don't want to take the time. I'm sure you can plug these values in. You can see that 11 plus 5 is 16. I'll have 33 minus 8 would be 25. Square root of 25. I'm going to scratch that. All right, so you go ahead and practice this. You problems 49 and 50, and then come back and we'll finish out the lesson. So here we have our problem dealing with the elephants, and they want us to compare. It's important for us to take a look at this information, compare the ages of two elephants. One has a shoulder height of 150 centimeters, and the other has a shoulder height of 250 centimeters. So what I'm able to do right now is compare their heights. But what they want me to do is compare the age. So what I need to do is find out the age based on knowing this height. Okay, so I know that one of them is 150 centimeters. And the other one is 250 centimeters. And then what I can do is solve both of these equations, and then I will be able to find the age of my elephants. So what I'm going to do is I'm going to go ahead and subtract 75.8 over here. That'll give me 74.2 is equal to 62.5 times the third root of time. And over here, when I subtract the 75, right, it's going to be 100 more than that one, so it'll be 174.2 is equal to 62.5 times the third root of t. And then I'm going to want to divide each of these by 62.5. So if I go ahead and I go to my calculator and I take 74.2 divided by 62.5, I'm going to get let's take a look at that again, 1.1872. 1.1872 is equal to the third root of t. I probably need to make a little more space here, so let's go ahead and do that. Right? And now what I want to do is cube both sides of the equation. So if I cube it, I'll get 1.6732. So basically 1.67 years old. Right? And then when we do the same process with the other item, right, I have 174.2 divided by 62.5, and then I'm going to take that item and I'm going to cube it. I get 21.65. So one elephant is just a little under 2 years, and the other one is almost 22. So one is almost 2, one's almost 22. They're 20 years different. So an elephant would grow about that 100 centimeters in about 20 years. So that allows me to compare their ages. They're 20 years